Bismillahirrahmanirrahim. This is a job recruitment question, and it was asked by a student from Bangladesh. And this is the circuit given. I have just redrawn it a little bit neatly. Let's see what is the question. Question says, explain operation of the diode circuit. We have to explain the operation. And then sketch V0 for the network of figure for the input shown. So we have to plot the V0. And what is given is that the forward voltage drop across D1 and D3, this and this is 0.6, and across D2 and D4 is 0.75. In the neat diagram, we have just shown all this. This is 0.6, 0.6, 0.75, and 0.75. So we'll work with this diagram. Let's take the positive half cycle first of all. For the positive half, top will be positive and this is negative. And since top is positive, this will be reverse bias because the positive touching negative of the diode. Similarly, negative touching positive of the diode and negative touching positive of the diode. So all four diodes will be reverse bias for the positive half cycle. And so we can show it by open circuit. And you can see that no current can flow through this circuit because everything is open. Now we come on to the second half, this one. Now it will be negative at the top and positive at the bottom. Now this negative will make this one forward bias, this one forward bias. Similarly, this positive will make this one forward bias and this one forward bias. But there is a catch here. The catch is that the moment this diode becomes forward bias at 0.6, and similarly this one becomes forward bias at 0.6, so somewhere here, then the current will start flowing through this circuit and it will not let these two diodes conduct, or any minor leakage current can flow through this, but this will remain till the end. So we can say that these two diodes will behave as off. Now let's draw the current. The current is flowing like this from here, 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 and then. And for ease, I have removed the capacitor. Now since it is purely a resistive circuit now, the current will follow this voltage, so it will follow the same pattern. And same current is flowing through this resistance, therefore the voltage drop here will also follow the same pattern. Except that now that we are measuring from this side, this is positive, therefore the output will be reverse, it will go up like shown here. You can see this is the input, this is negative half, positive half, no current flowing in the positive half. In the negative half, this is the output V0, same shape except that it is opposite because we are measuring from the opposite side, from this side. If you connect your voltmeter here, a positive voltmeter here, then it will be just coming down like this. Anyway, so this was without the capacitor. Now, what is the effect of capacitor? That is very important. And when we connect capacitor, we have to now visualize one thing that we have learned in the bridge rectifier circuit, that a capacitor is used for filtering, just like this one. And what is the effect? If this was the full wave, this capacitor will not make will make the output smoother. It will not let it go to zero. It will make it smoother. So exactly same effect will be here, and let's see from the next diagram. Now you can see this one is getting smoother, and it is not ending here, rather it is ending far away. So let's just draw a line to show This is the starting point. This is without capacitor. This is with capacitor. So the starting point is almost same. This is slightly late, of course, because of the capacitor charging, I guess. But let's see the end point. So the end point, this ending here, but this is not ending here. Rather, the end point is stressed. Like here, it is stressed. So same way, it is stressed. And so that will be the change in behavior with the capacitor. And now to have the magnitude of VO, we could have used this loop from here, this, but we don't know the value of R and C, therefore we can't use this loop. However, we can use this lower loop. By using KVL, we can find the voltage drop here. So from here, +6, then drop here V0, and then minus 0.75. So in this case, V0 will be 0.15 volt. And we can, the final diagram, we could draw it like this. This was the input, and the peak of the output will be 0.15 volt. So I hope you have been able to follow this. Now I'll attach a simulation diagram to give you an idea exactly what is happening. So if you were interested, just follow or see the simulation diagram. Thank you. Trying to simulate the circuit, and if you look carefully, the only thing different is that I have added diode here, single diode, but here I have used two diodes. Now I could not find, the question says that this has a forward bias drop of 0.6 volt, and this will have 0.75 volts. I could not find a diode. So just for the purpose of simulation, I'm adding these two diodes. That means if this is 0.7, then this will be 1.4 volt. So the same here. So what will happen technically is that only this diode and this path will conduct, because in the forward bias case, this will quickly turn on at 0.65, and similarly this at 0.6, and this at 0.6. So they will conduct, and the current flow path will be like this, from here, this, this, and to the source. I'm also added two current meters, ammeters, just to show which path is conducting, and you can see in the diagram. Another thing which was bothering me is the presence of a capacitor. What is the effect of this capacitor? That we'll also see. Our aim is actually to plot this voltage here. So I have used both. This is the input in the scope and also the output in the scope. So let's see. So now, since it is the positive peak, this is top positive and bottom negative, none of the diodes are conducting. They're all in the reverse bias case. Now we're going down, and the moment this crosses 0, you can see there will be some flow of current. Now let me just slow it down a little bit. You can see this current is now started flowing, and this is the path. And you can see this current is increasing gradually, 0.3135. This is minimal, where a leakage current we can say is 0.003 milliampere. So we can safely say that these and this not conducting, only this path is conducting. Now, what about the shape of the voltage curve? Since it is going through the resistor, it will just follow the shape of the input. So let me just enhance it speed. and you can see that this is now reaching the maximum point 3 almost minus 3 volt, and now it is going up. So the current should now be reducing gradually. You can see this is still minimal current. Now look at the shape of the voltage here. That is the question. What will be the shape of the voltage? Now it is following exactly the shape of the input signal. Same shape. The moment, although the direction is reversed because we are looking from here, this side is positive. Okay, so we stop here and we will now see the effect of the capacitor. Now this is not conducting anymore. Let me just stop it and connect this. So, and wire. Okay, so this capacitor is now connected, and we'll see what is the effect of this capacitor. We run again. Positive half, no conduction. The little bit current flow that you saw here was because of the capacitor was charged. Now let's see it's all stopped, and now we are going towards the negative direction. The current is flowing. Now look, this current is now going through two paths, and it is going faster through the capacitor. So it is now charging the capacitor as well. And if we stop here, there is slight difference between from this point to this, and this took little more time to rise because of the capacitor charging. Capacitor is taking time to charge. Run again. Okay, now it has reached full negative, and now see the capacitor is reverse charging. Now the capacitor has fully charged, and it is now again adding into the current, and so the shape is now, this is flattened slightly than this. This was going or following exactly same shape, but this is slightly flattened than this one. As you know from the full wave rectifier, when we add a capacitor, we call it filtering. It tries to smooth the output. So that effect is happening here. And also it took slightly more time. Now look here. This finished here at this point, but this one is finishing almost at the end. So it took slightly more time to discharge. It started late and discharging late because of this current or the discharging of the capacitor. So speeding up just to give you one more thing. The scale for this fan is different, 100 millivolt per division, and the red one is 1 volt per division. This was just to show you clearly how is the output looking. So it's about what 5.15 or 1500 millivolt here in this case. Okay, so I hope you have got the concept of the adding of the capacitor in this circuit.